Good afternoon. I'm Lieutenant Richard Rahidi, the president of the National Contract Management Association Middle Georgia chapter, and I'm here with Captain Richard Bartlett, president of the Agile Combat Support Junior Force Council here on Robbins. We're co-hosting today's event, a conversation on artificial intelligence with our special guest, Captain Michael Kanaan, author of the book T-AI, and then also the current director of operations at the Air Force MIT AI Accelerator. So before we get started, we'd like to just go over the logistics of this meeting. This is a live event, and it will also be a recorded event. The structure of this meeting will be to get to know Mike and hear his story. He'll share his experiences that led to writing the book. We'll have a brief moderated QA between Rich and myself, and then we'll open the floor for QA, for open QA. Some of you have questions already, and some of you will generate questions throughout the course of this meeting, but please submit all questions in the chat box. All of the questions will be answered in order, submitted in the chat box, and then be encouraged that any questions that don't get to be answered in this meeting, you may engage with Mike afterwards and email correspondence. He has completely welcomed that. And then last but not least, until you're asking a question, please ensure to turn off video and to have your microphone on mute. And so without further ado, Mike, after reading the book T-AI, it became quickly clear that AI is a multidisciplinary topic. It does require a strong understanding of one's brain and computing. It's a dual-use technology, and so it affects us personally and professionally in our supporting role for the military. And then, of course, AI itself can be a bit of a black box. What exactly is AI? But also one thing is crystal clear in your book is that AI has played a direct role in your career, and that started very, very early on. Can you share with us your story and your experiences that led to the book, and then your initiatives today at the MIT AI Accelerator? Over to you.
Sure, and thanks, Richard. And hi everyone. And I just wanted to say that I appreciate not only your work, but your care and the opportunity to share through storytelling. I think that's how we learn best. And perhaps the one benefit to this pandemic is that we're taking the time to discover and learn new things, converse on topics like AI that were generally an afterthought otherwise without a focus on this digital connection by necessity. And then furthermore, for us, I hope we can bring a little bit of a dogged focus on inspiring and understanding the topic to people, to our colleagues, to our family, to our friends and our neighbors who might not naturally think about a topic like AI if they aren't exposed in individually meaningful ways to them. Education on the topic outside of the traditional visions of engineering is what I think we should be most passionate about. And each of our stories on being inspired to learn AI and lead AI is going to be completely different. Mine began after graduating Intel school in San Angelo, Texas, and my first assignment was at the National Air and Space Intelligence Center, NASIC. In fact, I have no doubt that most of you on the call now either work closely with them or glean some benefit from that national treasure of ours. And arriving there, my first job was commanding a new mission. We called it ACES High, which was an acronym for the Airborne Queuing and Exploitation System Hyperspectral. It was a total first of its kind for us, and we were just a couple months out from flying our first missions in the Middle East, which is daytime in the Middle East, by the way, and nighttime for us in the States. So what's a hyperspectral imager? You see, it's a camera that works much like our eyes do, except better. You and I see in 3 color bands. A mantis shrimp sees in 12. One might philosophically ask, what does a mantis shrimp see that we don't? But a hyperspectral imager, it sees in hundreds. What does that mean? Well, it can measure the radiance from reflected sunlight off of a material. And when we look across the color bands it collects in, during the day, of course, because sunlight, we can identify certain materials that were spectrally significant in the spectrum of which it collects. Long story short, it was this which initially led to my passion for AI, because I forgot to say the year. It was 2011. What was happening? ImageNet. And ImageNet was led by Dr. Fei Li, where due to the rise of our ability to collect data, store it digitally, they put a bunch of pictures of things like cats. Everything's cats on the internet into a database. And about that time was the first time that computer vision algorithms that have existed, math for a long time, could outperform the human at certain tasks. And also, at least so long as we ourselves didn't kick the proverbial can down the road on AI, AI came out of its last winter that year too. When you think about our mission using the sensor, we were collecting this massive data cube that somehow we needed to send back via satellite data to be processed locally in Ohio, all while live flying in Afghanistan with only 16 of us there, flying the plane, moving the sensor, and doing all the analysis to, at a moment's notice, let an airman, sailor, soldier, Marine, etc. on the ground know there's something you need to be concerned about. Sometimes that was literally turns away, seconds, minutes for a convoy on the road. Because again, we could definitively detect and see what the human eye couldn't, such as nefarious materials that could kill or compromise our troops or our vehicles. And this was a big deal. And for those of us who knew how to frame an AI problem, it was perfect. But it was 2011. I was 22 at the time, running around saying, hey, we should do this machine learning thing. Now in commercial and academia, everyone would have said, well, duh. But in government, even at NASIC, you might as well have been out of your mind, Lieutenant Kanaan, which most of us feel quite often. And that began a groundswell because I wasn't the only one wondering, well, how much more could we have seen? How much quicker could we have told someone? What could we have done better? Who could we have better helped? How could we make smarter, right choices? And that's a perfect AI problem. And even without it, there are plenty of successes taking 37 tons of weaponized explosive material off the battlefield, where just 25 to 50 pounds smashed together is something that damages and kills people patrolling. And, cited and recognized as saying 2,500 lives at some pretty timely points in discovery. And for relative context on that number, this isn't just some number people throw out there. There's only been 3,500 deaths of coalition and U.S. troops there as of last summer. So it's not a lavish stretch bullet, to say the least. And despite any subsequent professional accolade or even personal accomplishment, it's the women and men on that mission, those airmen, that I think I'm most proud of to this day. And I don't think that'll ever change, because for most of us, it's always the first mission we love most. And from there, I moved on to be the director of target development in the counter ISIS operation, OIR, using data-centric models to make better decisions, and perhaps being largely successful back in 2015 as we became more cognizant of data mattering and things like visualization and structured data, and just, the group of us being a little bit older and more mature to journey along to an end state of AI as opposed to proselytizing about AI. But the point to all of this is that you could lead to better outcomes with data. And then from there to the Pentagon on the core team that stood Project Maven, and then ultimately co-chairing AI on half staff, and currently here at MIT in our new AI Accelerator partnership now with them. But in the end, it's just my story. We each have one. And what I hope we recognize is that the current state of AI has a role to play, and it will continue to do so. And furthermore, there are moments in our personal lives and professional pursuits when we just look in the mirror. We ask ourselves, do I understand what I'm talking about? Do I get the values and ideas and directions I'm espousing? Do I even know a little about how to get us there? And we're here now, so regardless of the demographic, young and old, senior, leader, manager, subordinate, everyday person alike, I think we each need to do that and hold people to account on that. I like the idea of teaming the techniques of the old with the ideas of the new. I mean, truly, age does not dictate experience in this new domain. For how long could you have possibly been doing the current state of AI? 8 years? Maybe? In fact, a young person like on the line now and us is probably the most experienced a group has to offer on a strategic imperative. So be inspired. And ultimately for us here, this just looks like the field of dreams approach. Build it and they'll come, allowing the next generation of young person or airman leader to make the future they need and the one they actually will deal with, and being humble enough for each of us to answer the question of what does the future look like? What does future warfighting look like? With an answer like, I don't know, but I want to empower you to pivot and make a decision. And with that, that's just my story, Richard.
That's an incredibly inspirational story. Really appreciate you taking the time to join our community. Now, Rich and we had a few questions of our own, and to maybe tee up the open QA and to generate some of those questions, there's one that I personally want to ask you. So what I remember from T-AI is that you have a compelling history, buildup of all history until you really start mentioning AI. I mean, you kind of literally start with the origin of the universe. And can you kind of share what was your motivation to structure your book in that way?
Yeah, let's jump in the AI conversation. AI is the greatest newly developing technology capable of profoundly enhancing human opportunity and experience, but it also presents a fundamental threat to the safety and security of our businesses and frankly humankind. And although it's now commonly employed as the foundational software and applications, products and services in everyday life, to the most sophisticated of business, geopolitical, and military pursuits, certainly, it remains entirely misunderstood by common citizens the world over. And worse, in recent critical years, it's been relatively ignored by democratic policymakers, while China, Russia, and other opportunistic countries have implemented its power to advance their international agendas and global disinformation campaigns. So most simply stated, AI is designed to capture, analyze, and then optimize human patterns and practices. Without care and control, however, it can be unintentionally or even purposefully infiltrate our privacies and even replicate and exasperate our worst inequities, biases, and abuses. So unlike other existing AI books, however, T-AI wasn't written to be an excited portrait of a utopian future, nor a dystopian sketch of all we should fear. It was undertaken to objectively address the current realities and the true future implications of AI. So the purpose was to explain the rudiments of the technology in an accessible and engaging narrative, and to provoke a common call that AI implemented in only ways consistent with fundamental human dignities and only for purposes consistent with democratic ideals, liberties, and laws. And it's a technology that's uniquely poised to advance the efficiencies and ultimate purposes of private and public entities alike. It's also equally capable, however, of compromising the logistics and legitimate end goals of our individuals, businesses, and government institutions. And either way, AI executes by assessing the patterns and predictable biases of humankind, and then evolving itself technologically speaking to reactively alter and enhance its subsequent analysis and prediction moving forward. Now, the challenge in writing the book was to excise my own patterns and biases from the narrative to create a work that would be lasting and equally accessible to a broad audience of readers from different cultures, countries, educational backgrounds, social perspectives, and political persuasions. So it's crucial that the finished book be as foundationally unbiased and factually accurate as possible, but that it still provides some intrigue and dynamic storytelling for a common reader. And because the human experience and perspective are the essence of what AI measures, predicts, and informs, I chose to explain the technology by weaving historical and currently topical anecdotes of our biological, social, and intellectual evolution as the most naturally efficient and informative means to drive the narrative. The story of AI from its origins to present to future iterations is and always will remain the story of humanity itself. So essential aspects of the human story were written as poignant themes throughout the narrative. And for myself, there was just no other book on the market that did that.
That's a very profound answer. Very profound answer, and it does make it clear to me that AI definitely illuminates all aspects of the human experience, and so for that reason, that makes sense now how you structured your story, and then it kind of segues into the nuances of AI, such as the biases that you spoke of. And so one last question I have before I offer to Rich is, I think you've mentioned in other events that AI can project the biases of its engineers, whether for good or for worse. And so what are some considerations that you can highlight for us to mitigate kind of those risks of bias in AI?
Of course. All right, so once upon a time when it came to interacting with our machines, our data, We had to explicitly code its input with a semblance of its output in mind. But because of some advancements, primarily in computer architecture, software, languages, and algorithms, by the way, read that as math, right? AI is just math expressing code to our machines. We don't any longer have to hard code this into the machine itself, which is really problem framing and communicating with the thing in front of you, a computer, in quite the same manner. They're just applications that are designed to analyze data and formulate predictions without any overall guidance from us. Now, half the time we get caught up on what is AI. That's the definition. That's it. It's how it will always be. So let's not rehash that over and over again. But it doesn't mean, however, that machine learning is necessarily safe from the effects or influences of our human biases. It's not. Just because it's an algorithm or it's based only on data doesn't mean its output is neutral or objectively fair. And it's quite common and will be that all human biases, because we generate data, we memorialize it around us, will be reflected. And when they are, it stands to reason that any analysis, strategy, or prediction based on that data is biased as well. And worse, what we're seeing now is if decisions are made or actions are taken on bias analysis, then the underlying biases, of course, perpetuate and possibly ingrain historical or cultural inequities even deeper into our lives. Now, the steps for us to ensure that doesn't happen, they're difficult to accomplish, but they're not impossible. They require conscientious and concerted efforts at the development and training stages of machine learning applications, plus attentive analysis and oversight at the implementation and use stages. And what's interesting is all of a sudden you start to realize that unlike delivering some product or an airplane wing or something manifested in physical reality, it takes a lot of concerted effort along the entire phase, which means different career fields, different interests, and people looking at it in different ways, because most of us believe we're fully aware and consciously in control of our bias inclinations and opinions, and that we're able to intentionally include or exclude them however we see fit during, the decisions we make every day. But we're not. The truth is we're unable to separate ourselves from our biases or biases from ourselves. And we're not really aware of the many prejudices we hold and unaware of the ways they influence our behavior. So regardless of how objective, unbiased, or enlightened we think we each are, we have underlying unconscious tendencies and tastes, but right along with aversions and distastes. It defines who we are, it defines our mission, and it influences, to some extent, most everything we think and do. And it's not necessarily a bad thing, right? It defines literally what food we like, and it keeps us from danger in certain ways. But when their thoughts and preferences are memorialized in data, then so too are what we do. Now, the problem is this. It's not possible for AI to determine if our patterns of behavior are based on fair and desirable attributes or if they're unfair and undesirable prejudices. So as we think about AI applications we might use, we should hope that its worldview, for worldview, data is akin to experience. Now imagine, if you would, an X and Y axis. On the Y axis, we'll put worldview, and that's the data it was trained on. What we hope is it's representative of its scope, and we'll place scope on the X axis. That is, how many different people will it interact with? What is it used for? And we want that to be somewhat measurable. For instance, I certainly don't want an Alexa in my home only trained on Southern white gentlemen or people from Northern California. Its scope is too large. We want to make sure it hits a sweet spot there, which also looks, somewhat like first steps towards regulatory actions. But for what it's worth, it's a liability. It's a lot of work to realize and worry about for many people online now, frankly. But it's a good liability. It's what makes us different than countries like China and Russia who don't care. So when we make mistakes because of bias, and we will, we see it in the public setting all the time, Amazon hiring old white people. The point is, though, is that we have a conversation afterwards and we change. And I think that's something special. So diving in to realize those biases flip the paradigm from us being afraid and almost paralyzed to move forward.
That's a very, very profound question. And my personal takeaway there is data is, of course, the experience to AI. And so how we think about data, how we curate the data sets, it can certainly make or break AI. And so that's a very insightful answer. I
It's
appreciate
our
that, Mike.
experience and mission, right?
Go ahead,
You
man.
know,
And so, a
Okay.
good segue from data is, Mike, is, I work in electronic warfare. And so we consume, a lot of data. So the question then is how do I know if my organization is ready for machine learning, and what are the skill sets required within my organization to have in order to enable AI?
This is a good question when we think about how do I know if I'm ready or if it's even appropriate. And I'm often asked, what makes a good AI problem? And tapping kind of my inner Tom Petty here, the framing is the hardest part. So first, despite what one may intuitively think, AI isn't going to replace people, especially the worker bees. AI will actually have the greatest impact with your subject matter experts or the top of your workforce. So as leaders, when we're framing an AI problem, we want to look for three criterion or the stuff we have currently. The first is high volumes of data. So think of a ton of Excel files. We all have those. The second is high velocity of data. So think about you're making decisions quickly, or that's a good thing to make decisions quickly. But here's the twist. Highly accurate data. And most of the time, we start at the lowest rung and we're failing on the third criterion. What we generally do is just espouse the notion that AI will be the advantage in some domain. Then we bang our fist. If we have AI working on X, insert a business function or a certain military concept here, then we'll most assuredly win. Wrong. In order for AI to be effective, you want to provide it many examples of what you do. So think of AI as a flashlight, a mirror, or maybe a canary in the coal mine. It illuminates otherwise undiscovered and latent patterns in the world around us. And I think when we start to think that way, we start to frame good AI problems. We need many examples to discover patterns. And that brings me to a note about strategy, our programs that we're thinking about. Yes, we're in the digital age. Yes, tech is profoundly innovative and cool, but whether you're in the private or public sector, capability is not strategy. And again, from the rooftops, we should stop advertising capability as strategy. There are a number of recent strategies and business plans being released, which essentially say we have a data problem. We need to make decisions fast and accurately. So we're starting to hit those criterion. Then we yell, let's do AI. And then because of that, we'll dominate our industry and competitors. And I love AI, but AI alone is dangerous strategy and it's rampant. AI is just a tool, albeit it's extremely powerful and has some implications we need to consider and evaluate carefully, but is nothing more than just an arrow, a crucial arrow in your strategy quiver. The takeaway is this: you won't win because of AI, but you're definitely going to lose without it. But it or any other standalone capability is no strategy at all. It's really just a lonely chess piece on the international board. So when we think about how we use it, think of it more as that puzzle piece that you need to discover a pattern you don't see, and then empower a user, a human, to make decisions off of that. And we often talk about the OODA loop, right? Think of AI as really effective along the observe and orient portion, informing us to better decide and act later.
Thanks. And so the other piece of this that I had is what skill set within my organization, if I am going to bring in, to start down that path of machine learning, what skill set should I be looking for within my organization?
Well, so there are a number of different focal points we need with AI. So we need a technical perspective. And I point people towards section 241 of the 2020 NDAA, where it took a lot of work, but it is legislation now where we will measure and treat language, computer language, aptitude and proficiency the same as human foreign languages, and directs the Department of Defense to measure them, track people, provide education, and furthermore, even special pay in the next 2 years. That's a technical perspective. Can I speak the language of the machine? But then you also have a managerial perspective. And I think about this idea that we need to help everyone understand and be able to see it. So I think of, maybe more broadly, we'll pull back for just a second. If you don't think you're paying for something, that just means you're not the customer, you're the product. And that's primarily only in digital environments. And it recognizes almost, this idea that I hope for us as managers of AI, while we have technical experiences, that we kind of the proverbial, I know it when I see it, to recognize it through reminding us to ask the question like, hey, is AI affecting that? So as leaders, we want our workforce to bake an eye for AI per se. Not only its effect on everyday life, but flipping it to figure out our solutioning. What's an AI problem? What's appropriate for us to use it? And I think of it in this way, a sort of anecdote from 4 years walking in the Pentagon. Every morning, I would walk into the building, and for whatever reason, the elevator was on the 5th floor or the 4th floor. But everyone was streaming in from the ground floor that day. And then when you're leaving, it's all the way on the ground floor, but not on the top floor. Now, the elevator companies have figured some things out, and it's a perfect machine learning problem. And now when you walk into certain elevators, you don't have buttons inside, but buttons outside. It's because they're optimizing the experience. I hope for us as leaders, we want to create this kind of eye for AI and inform it, but we have technical proficiencies and then managers of solutions. And for artificial intelligence and data and applications that we're going to have, it's not about these giant programs, but it's more about apps and products. And I know you guys talk about that all the time of what are we managing here? Looks wholly different than it once did. So the managerial aspect of I know it when I see it, I think is probably the place we're lacking most.
Thank you.
That's a very profound problem, and one thing I'm personally taking from that, Mike, is so AI is an enabling technology, and so it very much can be invisible in the wild, so to speak. It very much can be invisible. You would have to be able to know that it is an AI application. And so on that note, to kind of build an intuitive sense for how powerful AI can be, can you identify what you believe is maybe a very basic, simple example of AI application, and then maybe at the extreme end, what is the most complex to your knowledge that you can share? What's the simplest example, and then what's the most complex?
When we talk about Google search, so number one, I think, let's talk about the way that it impacts us the most. I think there's a really powerful moment people have when you call up one of your friends or a family member and you do a Google search on the same word. Totally different things come up. It like rocks your world. You're like, you are literally looking at different information than I am based on your patterns and behaviors and trends and essentially what you want to hear, right? Bolstering echo chambers. So number one, that's an example that you feel every day in life. And I think it rather rocks you to your core when you wonder how people get the information that they get or the insights they're taking away. But the simplest one that you see every day are spam filters, your email box. It's largely powering the one thing you want to have is not get emails I don't want. And spam filters were originally rule-based. It was basically filter out messages with the words, Ethiopian money inside of it, and anything that just comes from an address you might know. But spammers are smart, and they changed all of that, and they updated their patterns and messages to work around it. So our spam filters nowadays have to continuously learn from all sorts of different signals, whether that's activity from an IP address in a certain area or things you don't like reading and you always delete, or some pivots on words and messages, maybe not Ethiopian, but Rwandan or something that we see in, many of our phishing problems that we have throughout the world. So it personalizes things, and spam is a really good example of a very simple function you see in everyday life. Now, on the flip side, the most advanced examples that we're seeing is in a concept and technique called reinforcement learning. And we have a long history, I speak about this in the book actually, about why games matter. And why is AI developed on games in general? On chess, then the game of Go, and now you see the most advanced techniques playing out on StarCraft and Dota, which interestingly enough, right, they're war games. And this concept of reinforcement learning, this concept of teaming between different artificial intelligences, doing different tasks and coordinating together is probably some of the most complex stuff that we're seeing and where some of the leading companies are working. There's one more point to that, though, and there's an inherent duality to this stuff. We talk about deepfakes. Deepfakes are also extremely advanced reinforcement learning techniques and applications. Interestingly enough, however, a deepfake, that technique, is the thing that is most effective in measuring mammograms, for instance, for detecting breast cancer. And literally the same technique is the dis and misinformation we deal with every single day. I think that's something we need to pay attention to come to grips with, that at the end of the day, we need to understand artificial intelligence and how it works, because it's we ourselves and the purposes to which we put our machines is the principal problem and ultimate solution. And it's not going to change just because we say the word artificial intelligence. In fact, I wish we would just call them learning technologies. I think that helps us wrap our minds around it.
Thanks, Mike. So I got another question here. So, you have a lot of organizations coming online, like the JAIC and obviously the AI Accelerator. So how in the DoD are we capturing and testing AI and the lessons learned so that these can now get passed down to organizations at the tactical level who are actually trying to implement this?
This is an interesting question. And there are two things happening here. We need to experiment, right? Again, we learn best through experiences. So you see multi-million dollars, gigantic demonstrations of a singular capability, right? And I think that serves its purpose in inspiring the workforce, getting us to kind of realize the science fiction future we could have and why we would do it. At the same token, what I think for us to better test AI, and this goes for private businesses as well, is to frame it like this. Envision a world where for your project or program that you have the most elegant algorithm as a solution. It works, right? It's on the MacBook near me now. The question to ask then is, could you deploy it if you tried? And furthermore, if you can you change it or pull it back from throwing it over the proverbial fence if you needed to? And then furthermore from that, can you measure the data or the new insights, the new questions people are asking because you have that algorithm? And in this case, we are wholly lacking. There are not enough places, and this goes for businesses, where you could deploy AI if you tried and get into what I just described as a very virtuous cycle in machine learning, which is also why people can't keep up with your competitors if you get really into that kind of flywheel effect that's happening. So I challenge that we pay attention to those things. Now, on the flip side, what are we doing? The Joint Common Foundation from the Joint Artificial Intelligence Center, a number of efforts within Air Combat Command for platforms where we have data as a service, where we can represent the missions that we have and then feed that. The Chief Data Office on the Vault platform, which if you look at the OSD Chief Data Office strategy, it almost directly resembles and mirrors the Vault strategy. So at the end of the day, we have to pay attention to the underlying building blocks of AI, or else we'll just keep doing one-off experimentation and not truly realizing the best and most profound part, to your point, Richard, about AI, which is to get better over time on a continual basis at computer speed, right? So I think the most important thing is we ask ourselves, does the infrastructure, does the software, and does the data have an ability for me to deliver AI? And when you start asking that question, you start figuring out what we should actually be doing, where you have to answer, no, I don't have cloud native environment. No, I don't have container orchestration. All of these words become very important. And down to what I believe is most, important right now is to hack the bureaucracy by knowing the bureaucracy with smart points. For instance, case in point, we should be looking at strategic planning guidance right now and asking ourselves, does that have a requirement for new Python and Anaconda packages right now? Does it have a requirement in key performance parameters, for instance, such as commercially standard API? These tactical choices are the strategic decisions of tomorrow, and getting down to brass tacks on unlocking the ability for a local unit to realize AI is probably what's most important. And I do want to celebrate the people paying attention to common foundations to do so. It's practicable.
So that is a beautiful answer, Mike. Really, really appreciate that. I wanted to make sure that we save enough time for open QA. And I don't see any questions yet in the chat box, but feel free to ask any questions. Please turn on your video. And I'm inviting you to please turn on your video to identify yourself, which organization you work for, with your questions.
Rebecca.
I'm watching the chat as well, so I'll hop on Brenda Colton with an awesome question that I really care about, and that is graduating high schoolers. So let me give you a statistic. This year, we will graduate 50,000 people with the traditional vision of computer science or STEM for 500,000 open jobs. In reality, however, what ends up happening is that within the next 3 years, we will continue on this trend and this path, yet we will have, insert sort of a Dr. Evil reference here, we're going to have more than 1 million jobs available. So I think what we have to ask ourselves, both in our workforce, but also for society as a whole, is I don't care if you have a college degree. Have you done it? Can you do it? Do you have a passion to do it? How do we as a nation help drive down the gap is what matters. So when it comes to what the best degree is, it depends on what you want to do. If you mention electrical engineering, there are so many cool things going on with the hardware architecture of delivering artificial intelligence right now. If you're talking about computer science and the theoretical implementations of it, phenomenal degree to have. But a lot of people end up blending this idea of traditional STEM with I just need to code. And I think right now what we have is the barriers to entry on education have never been lower. So ask yourselves, if someone's going to college, what are they passionate about? Do they have the opportunity? But furthermore, you don't have to go to college to learn these things and have really lucrative, worthwhile, meaningful job experiences.
All right, Rebecca, I'm having a technical difficulty offering the spotlight to you, but please go ahead and ask your question.
All right, thank you for the opportunity. My name is Rebecca Less. I am from AFL-CMC, which is Air Force Lifecycle Management, Human Systems. And right now within AFL-CMC, a huge push, specifically by Dr. Roper, is digital engineering. And he's published quite a few articles. I think some of them is called There Is No Spoon and Bending the Spoon, to foster digital engineering in the acquisition process. And I was just wondering if you have any insight on how AI could be used to kind of foster this push for acquisition, specifically as a young engineer in the acquisition world. Thank you.
Super meta of you, Rebecca. So this idea that we can use AI to look back upon ourselves to further the pursuit of AI. And it's an awesome paradigm shift when we're so often afraid of it and what biases it could illuminate when otherwise, do you remember when I spoke about we want to provide artificial intelligence, all of the examples of good work we want to perpetuate? So in terms of acquisition, reform, and approaches, I think to myself of collecting in a standard way with AI ready data, which is not exactly picking up a whole bunch of hard drives and saying, oh, let's do AI with it. It takes an entirely different engineering approach. But what we want to do is collect the best examples. For instance, I think of the best examples right now being procuring commercial items in this space if we want to advance digital engineering and AI. So I have a little bit of a rant on this, but this is kind of the perfect audience. Under 10 US Code 2377, FAR Part 10 and FAR Part 12, which is the DoD guidebook for acquiring commercial items, and in line with the 16 and 18 NDAs, which were very explicit about these things, to include the 20 and 21 most recently, the Air Force must first conduct market research into the availability of commercial items to meet its needs, and then use that research to determine whether a FAR Part 12 or a FAR Part 15 contract is appropriate. But if commercial items are available, 2377 and its implementing regulations prohibit the United States Air Force from entering into FAR Part 15 developmental contracts. And additionally, both 10 US Code 2377 and FAR Part 10 require ongoing market research for the pre-solicitation, solicitation, and task order phases, ultimately, of IDIQ procurements. So it's concerning, therefore, that when we're looking to get to this digital engineering end state, and perhaps using AI to find where it's been most effective and who has done that, it's concerning we mostly don't do this at dollar signs below the threshold of what ends up constituting as open injunctions. And what it really means is what we want to answer are three questions. Are commercial items available? Can commercial items be reasonably modified? And or can the requirements be modified? In that case, a yes to any of those questions, which, by the way, in digital world, especially AI and digital engineering, is a resounding yes 99% of the time, then we should be doing FAR Part 12. I would love to see something to your point of, are we looking for those examples? Have we teed up good examples so that we can perpetuate those to more, and then look for trends underneath good examples that help us gain success? I hope that's a okay answer for you.
No, that is a very good answer. And I think Dr. Roper, reading his articles, does kind of allude to that by he pinpoints certain programs that have utilized digital engineering in order to speed up the acquisition process. And I think transferring that from a paper article form into a development of an AI form is a great path forward. Thank you very much. And thank you for your time.
No, appreciate it. And to Brenda Colton's point just a moment ago, and child looking at Ohio State, one of the principal investigators I work with right here is a graduate of Ohio State, and their computer science degrees are terrific. By the way, I'm from Michigan. I'm Michigan Wolverine, so this is a little bit much for me to say, but they're making a great choice by going there.
All right, I think Jason Pickard is next. Go ahead and ask your question, Jason.
Hey, Richard, thanks for the opportunity. As a point of order, I don't have a chat pod available to me, so that may be why it's a little quiet on your end. So I'm a contracting officer for the next Air Force One over at Lifecycle Management Center. I'm also a Lean Six Sigma Master Black Belt. And as working in the acquisition community, we have got data all over the place. But the thing is, it's so unstructured. Like our contract specialists, they've got great spreadsheets that are in some sort of desktop and things like that, which to your point is not data or artificial intelligence ready data. And some of our databases will tell us CPARS, for example, contractors' performance, that the thing that we're really trying to measure eventually gets kind of watered down when it comes to through that CPARS process. From a big perspective, what are some things that you think we within the acquisition community can do to be able to help prepare ourselves for leveraging artificial intelligence in our acquisitions and contract structures and all that crazy stuff to help us in the future?
I love this question because I'm going to kindly refer to them as the Richards who are together right now. We spoke about it last night, actually, and it sort of dawned on me. The contracting acquisition world is here to service us as customers all the time. And then I wonder who services you. And you guys so often are giving to everyone else and when you could otherwise service yourself. So I think it's an interesting question to ask. How can we help ourselves? The democratization of AI platforms that are self-guiding, for instance, no and low code environments. And there are a number of kind of do-it-yourself AI platforms that are commercially available and are quite performant in a really cool way. I don't think we're paying attention to the platformic aspect of generating APIs, algorithms, again, through techniques that they all exist. The same algorithm that works at the pharmacy to detect potential subscription and substance abuse for anomalous behaviors is literally the same algorithm that would work in ISR operations. What we want to do is kind of democratize that, but we never pay attention to the platforms that we could live on, drag and drop Excel files, and then use algorithms to kind of optimize what we're looking for instance, filling in missing fields or some sort of PPB&E process we didn't quite see. The question, though, is when we get to that conversation, we never ask ourselves, is that legacy database worth the squeeze? So we're consistently trying to take something legacy, which with lots of, by the way, very authoritative, or so we believe, information, but it also might not be representative of everyday business we already have. So to your point, when you say we should use machine learning to discover these things and help us get to things in a structured manner, the question is, imagine you had that algorithm, you could do nothing with it. So it would point you towards doing platform as a service for yourself to house those data sets and sort of unlock training quality data to employ AI with. And that's very explicitly why I wrote the Air Force Artificial Intelligence Strategy the manner that I did, as priority one, software as a service, data as a service, infrastructure as a service, and platform as a service as preferred commercial acquisition first. So we could get to doing what you want. It's just we don't always just take the time to ask ourselves, is the legacy thing we have even worth the squeeze? If not, let's just pay attention to the platform we live on.
So I think Mr. Peavy, I think you were next, sir. Go ahead and ask your question.
Hello, sir. David Peavy. I'm the lead engineer for the Advanced Capabilities team for AFL-CMC-WNY, the EW and Avionics Expo. One question I'm getting asked a lot, and I'm literally trying to draft up slides to do it now, is to provide a definitional difference for machine learning, advanced or artificial intelligence, and cognitive. And don't need, I know you could probably talk an hour for that, but is there quick differences that I could use when I talk to some of our 06 level, kernel level customers to help them better understand the difference? Over.
Of course. Remember I mentioned cats are all over the internet. Let's use an acronym. When we say artificial intelligence, it is a concept that is an umbrella approach that encompasses many different disciplines underneath it, whether that's good old-fashioned AI, whether that's symbolic representation, or whether that's machine learning. So AI is just a concept that a computer could do something once deemed in the domain of human, which makes us keep kicking the can down the road on AI, which makes people start talking about cognitive things. Machine learning is an application of artificial intelligence that, if presented data, it can change on its own over time with that presentation of data. And that's largely led by a technique called deep learning through neural networks. So you have concept, application, technique. And I think that way we're operating kind of with some precision in language. The limits of my language mean the limits of my world. And in that case, also not confusing the people we work with.
Follow up. So when you say cognitive and AI, is that sort of synonymous? Is that what you were trying to get at? I get your machine learning description.
Yeah, I'm really not a fan of anthropomorphizing AI at all. And when they say cognitive, I bet they're talking about neuromorphic computing, which, anything brain inspired sounds great. I think that we don't need to distract ourselves with that, because it kicks the can down the road again, when we should just delineate the various applications underneath the field of AI, which, when it comes to the cognitive functions, they're really talking about this approach with symbolic reasoning and good old-fashioned AI. Let's just break out machine learning from that, and then we start to be precise.
Follow-up question, because that helps me out a lot, sir. Is there a good central location or document or book that describes, you have AI and then you have the different tools, like you said, machine learning, the neuro, I forgot what exact term you used, that lays that out, because I'm dealing with different technologies in those different areas, and being able to lay that out to them would be helpful.
Yeah, I mean, it's something I write about quite consistently. And why don't after this, I just send Richard and do the favor, and I have some language that explicitly lays out the different fields of artificial intelligence itself, and maybe just like a kind of 10-page format you can steal from. It was a chapter I wrote, so I'm happy just to forward you that language.
Awesome, thank you, sir.
You're welcome.
So, Mike, I personally had one question before we close up here, and then would like to give your contact information for any of those follow-up questions. So earlier in the meeting, you talked about some of the things to look for when we're looking for use cases, and I think what you were getting at is machine learning use cases. You talked about, for instance, we might have a use case for AI if there's high volume of data. And we also learned that data is really the experience to AI. So there's high volume of data, number one. Number two, high velocity of data. So there's a need for decision speed. And then number three, you talked about the accuracy of data. Now, I'm a complete rookie here, but I would imagine that one of the hardest things to find out is the accuracy of the data. Right, the accuracy of the data. So can you talk about what considerations we should take when we're trying to make sure we're preparing the right data set for a machine learning application? What are things we can do?
Yeah, when we talk about artificial intelligence to the DoD, we immediately jump to JADC2. We jump to ABMS. We jump to warfighting, which by nature, warfighting, is there's low representation of. We don't do it often. And one would ask, how do we perform in it? It's very difficult to measure, depending on how you ask yourself, right? Am I, diplomatically performing well, informationally performing well, militarily performing well, economically performing well in our instruments of power? What I think is lacking, however, is that, remember I mentioned that artificial intelligence, machine learning in particular, which, by the way, machine learning will, if nothing advances in AI, the current state of machine learning will profoundly affect the world for the next decade. So let's scope and be pragmatic and focus on that for now, For myself, when there's a fire at the door, I'm not always worried about the lightning in the distance. But what we want to do is create representative data sets to test through that. So I had mentioned, let's say that your responsibility is to deliver anomaly detection algorithm, for instance, on for an ISR customer in A26 or something, or some unit, that they want to discover anomalous patterns of behaviors in cash expenditures from some nefarious agent we're paying attention to, right? How much data do we have of that? Could you deliver it if you tried? Is it even right? What I would rather see people do is say, let's depict that problem, this optimization and discovery problem, in an unclassified data set or something that's accessible. We'll build it there. We will get experienced with how it works. Then we pick up that algorithm, we bootstrap it, and when it's performant, when we know our business well, we start deploying it into those few shot or low shot opportunities where there's not a lot of representative data. I think being able to crystallize the problem you're trying to solve in something that's largely accessible, where you can experience the process, is where we should start. And then we can start deploying it into those higher risk areas where we don't necessarily have all the tools or access to the tools that we might have. And even if there are some concerns in the security of artificial intelligence from black box attacks and the like, but in reality, there aren't that many techniques. And provided you understand your data and it is secure, it's just being retrained to something else. If they don't know what you're retraining to, well, there's an inherent safety behind it. So I hope that we kind of represent and randomize data sets and practice through more than we do, as opposed to trying to solve the big hairy problem every time.
That definitely makes sense. And there's so many things you hit on there. And because I learned that definitely AI helps us understand the problem space. But if we don't understand kind of the problem space that we're already managing, then, when you talked earlier about the legacy application, maybe, or use case within the contracting environment, if it's not scalable, if the juice is not worth the squeeze, maybe that's another consideration for that data set, just not being worth it. So this has been a really profound, awesome meeting. We really enjoy the experience here, and we wanted to thank you. And there's about 2 minutes left. You don't have to apologize, but we were wondering if you have any closing remarks, Mike.
At the end of the day, I just want to say thank you to you guys. I genuinely believe that one airman, one CGO, one young FGO, a group of people pursuing the same idea can upend the entirety of the system. And as we look back upon these moments in 2021 at a critical inflection point, I hope to goodness one day we don't look back upon these times asking ourselves, well, I wish our eyes were more open, or calling this time the great nap, while we could have instilled and inspired change. And what I hope we commit as customers to you is to better communicate what it is we know, which, right, it's expressed here, that you're like, oh, I get the language. Training quality data is a keyword I need, but I didn't have that expertise necessarily, so that we speak your language and that you speak our language. And I think the cool part about this generation is we actually talk to each other. And if we have more of that, then we'll have smarter requirements and get to the end state we want, because I think we're largely on the same page. We just want to ensure we don't talk above, below, past, or beneath one another. And on AI, we're doing that. But just with some simple education, just paying attention to it, learning is a lifetime sport, I think very quickly we can fix that problem. So thank you.
Thank you, Mike. Once again, we really appreciate it. So this meeting was recorded, and it's unclear whether we're going to publish it eventually on YouTube or MillTube, but it'll likely be one of those two. And so once again, we want to thank you, Mike. I want to thank Captain Bartlett. I want to thank all of the members and the guests and attendees who could make it out. We did list Michael's email in the chat box. He has definitely welcomed any follow-up engagements. And let's all stay in touch and let's continue discussing AI. So thanks again,
Take
Mike.
care, everyone.
Appreciate
Have
it.
a good one, Mike.
Thank you.
Thank you.